Suppose this is your home, and suppose this is your campus, the place you study. So, what is the distance between your home and your campus? The answer is pretty simple. It is the length of road you undertake from your home to your campus and vice versa. Now, let me change the question a little bit. What is the distance between the word abstract in Indonesian language, as you can see on screen, with the word abstract in English? Well, this question is pretty weird. Doesn't seem making sense. But I tell you that I can provide a solid answer to this kind of question and making sense of this question using mathematics through a concept called metric space. Welcome to Abstract. Okay, before we dive deep into the formal definition of metric space, I would like to ask you together to extract certain properties from the real world setting of distance. Now you can see on screen that we have a plane with rectangular grids on it. Consider this is the space, like a yard or some kind of physical space. You can fill onto this plane points, but to make things easier, we will only put points on the intersection of the rectangular grids. Now let's suppose 2 points and call them point A and point B. Now come back to the context. It is distance. The distance between point A and point B can simply be given by the length of straight line you draw connecting point A and point B, which we denote by L, as you can see on screen. So, what is the first property about this? Is that the distance, the L, cannot be negative. It must be greater than or equal to 0, since it is true that you can't get a negative distance in the real world. So the first property we extract is that the distance between point A and point B is greater than or equal to 0. Now let me ask a question. Can the distance be 0? Yes, it can. If the 2 points are actually identical points, it means that the distance between these 2 points is the distance between the point and itself, and it must be 0. And you can give an opposite direction statement that if the distance is 0, then the 2 points are actually identical. So the second property that we extract is that the distance between point A and point B is 0 if and only if point A is actually the same with point B. Okay, let's get back to the original designation. Now we have to separate it, point A and point B, on the space. Observe that the distance from A to B is actually the same with the distance from B to A. And yes, this is true in the real world setting. So the third property that we extract is that the distance from point A to point B is equal to the distance from point B to point A. Okay, for the fourth property, let us add an additional point, as you can see on screen, a point C that is located right at the place you see it. Now observe that the distance between point A and point B is less than the distance from A to C plus the distance from C to B. You can try out yourself to measure this actual length, and you must have this, that the distance from A to B is less than the distance from A to C plus the distance from C to B. We can actually have these two inequality to be an equality if point C now is designated as you see on screen. Now in the setting we have that the distance between point A and point B is equal to the distance between point A and point C plus the distance between point C and point B. So this is what we must take note, is that the equality can be obtained if point C is located on the line connecting point A and point B. So to compromise this property regarding an additional point C, we can say that the distance from A to B is less than or equal to the distance from A to C plus the distance from C to B. Now you must remember all these properties because this is very important and fundamental in the construction of metric space, as we shall see later. For this video it is enough, and I'll let you think more about it. See you later on the next video about the formal definition of metric space. If you like the video, give me a thumb up, and thank you.